Kian, stop messing around.
What?
I keep telling you every lesson, and you keep doing it. I'm going to speak to your parents tonight at Parents' Evening. And don't make that face at me. Okay, guys. So, objective. Be able to round numbers to any given accuracy. So here's the word accuracy that we need to start using properly. Okay? Now, do you know what? I always start with a 3. I don't know why.
Psychology?
Okay. I have a number. I have lots of numbers there, but it's actually representing one number. Who can read that number to me? Kian?
35,721.5326.
By the way, it's good. Some people would say that it's 0.5326, but we don't do that because it's this side has special names like, well, what are the names of each value of each column? So the first column are the units, second column the tens, then the hundreds, then the thousands, then the tens, and that's what gives this side their name. So it's 30,000, 3 10,000s, 30,000, then 35,000, 700s, 2 10s, 20, 20, 2 10s, and 1. This side though still has values, but they are tenths, then hundredths, then thousands, then 10,000. Okay, so basically when we're rounding, the first type of rounding is just to round to one of those values. So do you all know what rounding means? What do we do when we round? Not actually do, but what is it, the whole idea of it? Yes, Sushi.
So that it makes it easier to write down numbers because, for example, if in a football match, 52,199 people appeared, you wouldn't write all the numbers instead. You would just say 50,000.
And the reason why that is, it's not necessarily to make it easier. It's because you don't require that level of accuracy. So, how many people are in a football stadium? Well, I don't care how many to the exact person. I want to know roughly to the nearest, what we would say, to the nearest 10,000, because we've decided that's important. If I were to ask you to tell me how far it is from here to Montreux, what would you say?
It's approximately however many kilometres.
Okay, so you just say 3 kilometres, if it was, yeah? Why would you not say it's 3 kilometres, 425 metres, 10 centimetres plus another 3 millimetres? Why would you not bother?
Nanometers.
Because you don't require the specific amount.
Yeah, you don't need that, because I can't actually walk millimetres anyway, so what's the point in knowing millimetres? Same with centimetres. Sometimes it is necessary to do distances with metres and not just kilometres. Like what?
Yeah. Like you arrive at your destination, and you're at a major point and actually go somewhere near.
Yeah, so when the distance is smaller, you might want it in metres. You know, it's 50 metres in that direction. Okay. What about when you're running a race, an event? Is it? Well, every event is roughly a kilometre. No, because you have 100 metres, you have 200 metres. Why don't we ever have 105 metres? Well, actually, we do have 110 metre hurdles, but you know, we don't have 105 metres because it's just not worth haven't we? We have a set amount. So we have times when rounding happens because we don't need this level of accuracy, and that's what I need you to understand. So to the more information you are given, potentially the more accurate your answer is going to be. So quite often people would say accuracy is about how well you've done it, but it's not. You always assume you do everything correctly, but it's how much detail you do. So what we have to be able to do is round to the nearest blah blah blah. So for instance, the nearest 10,000, the nearest 1,000. Oh, sorry, I did 10,000. Nearest 1,000, nearest 100, the nearest 10, the nearest whole number. Okay?
Infinite figure?
It's slightly different. We're going to do that next. So to round to the nearest, you don't say to the nearest significant figure. Okay? So this word here, round to the nearest, we're normally using, well, we are using each value of the column. Okay? So if I asked you, are there any rules you know about for rounding already? I'm sure you do.
5 and up is round up, 4 and down.
Yeah, so well, basically we say, well, how much do I need to assume I've got a full next one? Okay, and we say, if you've got half or more of the next lower level down, accuracy down, then you can have another one. Okay. Yeah, Kian?
Why did they choose step 5 to be rounded up?
Yeah.
Is there a specific reason for it?
Well, I guess I could say, why would we choose any other number? Why would we choose 6? Why would you? I think they've just gone for, it's the glass half full type of thing. When do you consider having a glass of water? Is it when you've got, how much would you need? So if I've got half a glass of water, do I have a glass of water? Maybe that's what they did. Halfway. Go on.
Technically, the glass is always full. It would be, if it was half full, it would be half full and half full.
I know you've added full. If I have a glass of water, I didn't say how much, so you'd always have a glass of water. It said full glass of water. Full is full, no? That's like me saying to you, I'm going to give you a full packet of sweets, and you've only got 2 in there. That's full. Anyway, so what we do is when we round, we go to the next level of accuracy. So for instance, let's do this number to each one of these things. Right? So this number to the nearest 10,000. Kim?
40,000.
40,000. Would you like to explain?
It's because to the nearest 10,000, it's 35,000 approximately, and the 5,000 is usually round up.
Yeah. So when I've got a 5 in the next, so this is the column that I want to round to. That's all I'm interested in, just that column. The rest of them, I don't really need that level of accuracy. But what I do have to consider is the next level down. Everything else can just go straight to 0. They do not impact. All right? So for instance, some people would go, so that's a 7, so that rounds, but this is a 2, so it rounds it down, so this is, and they keep going forever. Okay, but it's not. Basically, you go the one that you want, then the next more accurate column, the next value down, and then you decide, do I have enough there to make another one? And this one we do. So that's an answer some people would give. Would you like to explain why some people would give that answer? And it's incorrect. Why would someone write 4 if I said round to the nearest 10,000? Why would someone write 4? Is he? Yeah, so they kind of go, well, there's 4 10,000s, so I'm just going to write 4. Now, I always like to explain this and say, right, you can't change the value of the number. The value has to be roughly the same. So, for instance, I said to you, I'm going to round the number of francs in your bank account. And you've got 35,721 francs in your bank account. I'm going to round that to the nearest 10,000. You've now got 4.
Yeah.
You'd be like, hang on, there's something wrong there. There's something wrong. No,
Been
that's not even going to buy me half a Big Mac. So you can't change the value too much, right? So it's got to be roughly the same. So think like that. So we've got definitely 40,000. Okay. Sushi?
Isn't it true that no measurement in real life is exact? It's always rounded up.
Yeah.
Because if you say 1 centimeter, if you take it on millimeter ruler, there'll be something left. Then you can keep on going on.
Yeah, definitely. You can always go down to, if you're a scientist, you go down to molecular level. There's a little atom going past the edge of the. Yeah, no, you're right. But you always have a level of accuracy that you need. Louis, to the nearest 1,000. 36,000, good. Okay. Daniel, to the nearest 100. So which number's in the 100 column?
The 7.
The 7. So basically what we have is 3, 5, 7. These ones stay the same because they're above the level of accuracy. So it's 700, yeah. So these, the 2 and the 1 that we've got, we have to look at the 2. The 1 automatically turns to 0. So we go 3, 5, 7, 0, 0. Leah, the nearest 10.
35,720.
35,720. And, yeah, Ben, whole number?
35,722.
Yeah, good, because we have to go into the decimals. What's your hand up for, Sushi? What do you want?
We can keep on dividing in decimals too. Sorry, rounding in decimals.
Well, hang on. So, yeah, don't push too far forward before we get there. So we've got to the nearest, but as you said, we can carry on. But the language is a little bit different now. So instead of rounding to the nearest, we round to a number of decimal places. Okay? Right, so for instance, so we have a question mark and then decimal places. Alright? So for instance, in this number, how many decimal places do I have, Sushi?
4.
4. So this number is currently given to an accuracy of 4 decimal places, or to the nearest
10,000.
10,000. Yes, so it's in the nearest 10,000. So I could say to the nearest 100th or the nearest 1,000th or so on. But what we actually do is we say to a number of decimal places, and that's what you get in a test, for instance. So this number could be rounded to 1 decimal place, 2 decimal places, or 3 decimal places. Why can't I round this number to 4 decimal places, Ben?
Because there's
Yeah.
not enough numbers.
There's nothing else after that, so we only do the first 3. So what is it? So we're going to obviously 3, 5, 7, 2, 1. That never changes for all of them, because when we have to a number of decimal places, the whole bits don't change. It's just the decimal places. So, Yadami, to 1 decimal place will be 35,721.5. Tatiana, 2 decimal places.
35,721.53.
Yeah. Kian?
35,721.533.
Yeah, 533. So that's the only one that we had to do. Okay. Easy now. I think you're all fine. Anyone have any problems with any of that? No. There's obviously challenging questions. Now, so we get this finished before you have to move on. We've got another lesson today, but I want you to get on with the work. The next one then, so if it's not to the nearest 10 or 1,000 or the nearest, or to a decimal place, is to significant figures. Okay. Now, who's not heard of significant figures before? Okay, so this is the important one, isn't it? Significant figures. Alright, so I could say to you, for instance, so let's go back to 35721 point, what was it? 526. Just have that. Right. How many figures is that number to at the moment? Sushi?
Eight.
So we have 8 figures in this number at the moment. Alright. What does the word significant mean?
Major.
Yeah. So if I say the most significant thing that happened to me today is, so the most important, yeah, or the most eventful, the most memorable, whatever, however you want to think of it. But significant means, yeah, probably in this case with numbers, the most valuable. And again, significant figures, it's important to think of money. Right? So which number up there is the most valuable number? Archie.
30,000.
The 30,000. So this is the most valuable number up there. Some people would say which one? If they didn't really understand. So the 7. They go 7's the highest number, but it's not, is it? It's the place value we're looking at. So 3 is what we would say is the most significant number there, the most valuable. The next one, Sushi?
5.
5. Next one?
7.
7, and so on. As you go down, the most valuable. So if I said to you, round to one significant figure, the answer would be, Tom? So round to one significant figure. When I give you one significant figure, I mean I only want the most valuable. Exactly. Are you sure? But we're rounding.
Oh, so it would be 36. No, 40,000.
40,000 exactly. It's 40,000 to one significant figure. Sushi?
I didn't know what it was, but I guess this is the same thing.
Fair enough. If I said to you round to 4 significant figures, what would you say, Daniel?
221.
Don't start at that end. Always start the most valuable. So I'm allowed 4 significant figures would be keep that one, keep that one, keep that one, keep that one,
Oh, yeah,
but
and
so the same rules apply. So the answer would be 35,000.
35,000.
20.
We
Exactly.
should make a video.
So it's the same.
It's recorded.
It's
I
the.
think that's 2 videos.
It is recording Sushi.
Oh.
So it's the same rules, but here's the deal, right? This is where significant figures can change and confuse people a little bit. So we've been working with that number a lot, but just to finish off, what if I said to you, here is a number.
Oh.
Okay? If I said to you, round to 2 decimal places, what would you say? Sushi?
0.
Sorry, wrong.
Is it 0.51?
No. You've changed the value of my number by doing that. Amon?
0.00.
Yeah, we should do that, shouldn't we? I've asked for 2 decimal places. It has the value of 0, but we need to write it down. So decimal places, fine. If I said to you round to 3 significant figures, Cami, what would you say? Pardon? 0 point. You'd say 0, 0. I know exactly why you've said that, but it's not right. Izzy?
0.000511.
Exactly. Which number is the first significant number there, Archie?
5.
The 5.
Oh.
These zeros are not significant other than they make sure the number's in the right place. But if I can't turn them to zeros, they're already zeros. Right? Just one more, just to check. 0.60002. Right? If I were to ask you to round this number to 2 decimal places, not decimal places, sorry, significant figures,
60.
what would you go for, Tom?
I would do 0.60002.
Know why you've done it, but it's not correct. Sushi?
0.60.
0.60. Why was Tom not correct when he said this? Do you understand why he said it?
Yeah.
Yeah, because the 6 and the 2 seem like the most significant. But why is he not wrong? Is he, Joe? Not right.
Because 6 is less significant unless you have to continue.
Yeah, exactly. So once you've got to the first significant number, all the rest count. So the next 2 significant are only those ones. Okay? So I know exactly why you did it. Yeah. So 0.60 will be to 2 significant. Okay, so when you come back today, we'll get on with the exercise in the book. Alright, so I handed books out, we didn't need them, but next time we will.